2021 A-Level Combined Mathematics Paper 1 Part B question number 16. This video is being done outside of my normal schedule with the special request of user GAN-G6c. If you yourself have such special requests of videos of questions or lessons, then post them in the comments down below or in the comments of my other videos, and I will most likely check them and make similar videos to this in the future. Now moving on to the question. Since this question is quite long, I will be discussing the first half of this question until this point, and after that I will then discuss the second part of the question until the end. Now starting off with the first part, the question says, let the point P be given by x1, y1 and the line L be the straight line given by ax plus by plus c equals 0. Now given this information, we are to show the coordinates of any point on the line that goes through the point P and is also perpendicular to the line L are given by x1 plus at, y1 plus bt parametrically, where t is a parameter and an element of the real numbers. Now after that, the question then says, deduce that the perpendicular distance from P to L is equal to the modulus of ax1 plus by1 plus c divided by the square root of a squared plus b squared. Now here it's important note, since the question says deduce, we cannot directly apply the formula that we already know. Instead, we need to derive this formula and get this formula that we have right here. Now after that, the question then says, let the line L be the straight line x plus y minus 2 equals 0. So instead of ax plus by plus c equals 0, we now know the exact values and the line is x plus y minus 2 equals 0. The question then says, show that the points A, which is given by 0, 6, and B, which is given by 3, negative 3, lie on opposite sides of the line L. So given the line L like this, if A is on one side, show that B is on the other side like so. After that, the question finally says, find the acute angle between the line L and the line AB. Now to start off with the first part of this question, we need to consider exactly what the question is asking from us. So the question is telling us there's a point x1, y1 and a line L given by ax plus by plus c equals 0. So if we draw those out, we can see if we have a point here which is given by x1, y1 and a line L that is given by ax plus by plus c equals 0. So this line L is given by ax plus by plus c equals 0, and if this is a line of this form, we must have a squared plus b squared not equals 0. The reason you must have this is because if you do not have this, then both a and b could be 0 at the same time, which would lead to our equation of the line L not being a line. Because if this is 0, this is 0, then we just have these two cancelled, leaving us with just c equals 0, which doesn't mean anything. So therefore, a squared plus b squared cannot be equal to 0. Now given this setup, we are told that there's another line that goes through the point P and is perpendicular to line L. So therefore, this other line must be perpendicular to line L, which means it goes something like this, has a gradient like this, where the angle in between that line and the line L is 90 degrees, and furthermore, that line must also pass through the point P. So what we're looking for is this line right here, the line that is perpendicular to line L and also passes through the point P right here. So I'm going to call this line, the mystery line that we want, the line L dash. Now with this, the question is asking us to show that any point on this line can be given by the parametric form x1 plus at, y1 plus bt, where t is a parameter and an element of the real numbers. Now for this, we need to first find the actual normal equation of the line L dash. So to find that equation, we can consider the properties of the line L dash. Immediately we can see, since L dash is perpendicular to the line L, if the gradient of the line L is m1 and the gradient of the line L dash is m2, then m1 times m2 must be equal to negative 1. This is coming from our knowledge on gradients of graphs and the fact that if you have two graphs that are perpendicular, then the gradients multiplied together will be equal to negative 1. So considering this, if we take a look at the line L, we can see its gradient can be found by just taking this term and this term on the other side and dividing everything by b. So if you take ax to the other side, we get minus ax, and c to the other side minus c, so we get by equal minus ax minus c, and then if we divide both sides by b, we get the form y equals minus a over bx minus c over b. Therefore, the gradient, the term in front of the x in the y equals mx plus c form, is going to be minus b over a, or rather minus a over b. I apologize for my mistake. Minus a over b. Now, given this, we know that gradient multiplied by the gradient of L dash must be equal to -1. And therefore, we can say if m is the gradient of L dash, we can say directly m times negative a over b is equal to -1. And rearranging that, we can see the negative and negative cancel. We get m times a over b equals 1, and therefore m equals b over a. So from this we get m equals b over a. The gradient of the line L dash is b over a. Now with this, we can actually directly move on to the actual equation of L dash. The reason we can do that is because we already know one of the points on the line, the point x1, y1. So therefore we can apply the formula L dash given by y minus y0, which in this case is y1, since y1 is a point on the line, equals gradient, which is b over a, times x minus x0, which in this case is x1. So therefore we get the form y minus y1 equals b over a times x minus x1. Now rearranging this, we can see if we divide both sides by b, we get that L dash is given by y minus y1 divided by b equals x minus x1 divided by a. Now the reason you divide by b here is because we need this form in order to get the parametric equation that they're asking from us in the question. So now what we have to do is to take this form and simply say let, and write this whole thing again, y minus y1 divided by b equal x minus x1 divided by a, and then we have to write equals t, which is a parameter where t is a parameter, an element of the real numbers. Now from this, what we can see is that if we take this component and this component separately, we will get the y component that we have given in the question, and if we take this component and this component separately, we will get the x component given in the question. So if we take them separately, we can see from the y's we get y minus y1 divided by b equals t, and similarly from the x components we get x minus x1 divided by a equals t. Now, so rearranging and simplifying this down, we can see from this one we can get y minus y1 equal bt, and here we can get x minus x1 equal at. And rearranging once more, we can see we get y equal y1 plus bt, and here we can see we get x equal x1 plus at. And these two are the two formula we need, because we can see according to this, any coordinate x comma y on the line L dash can be replaced with x1 plus at and y1 plus bt respectively. So with this we can say, therefore, any point x comma y on the line that is required from us, or we could say on the line required, which is L dash, can be given by x1 plus at instead of x, comma, y1 plus bt instead of y, where t is an element of the real numbers and is a parameter that we can change from negative infinity to positive infinity to get any point on the line L dash. So with that, we have concluded the first part of the question and found that any point on that line that is going through P and is perpendicular to L can be given by this form. Now given this, we are then asked to deduce that the perpendicular distance from the point P to the line L is given by this formula right here. Now when they say deduce, they usually mean we have to deduce it from the result that we just found. So we need to use this result somehow in order to deduce what we need to find. Now what we are asked to find here is the perpendicular distance from P to the line L. If we consider our setup here, we can see since this line L dash is perpendicular to line L, the distance we need is simply the distance from the point P to the intersection point of L dash and L, which is this point right here. What we need to find is this distance right here, since that distance is already the perpendicular distance from the line L to the point P. So therefore, we just need to find this distance. Now to find this distance, I'm going to label this point right here as the point Q. And I'm going to label it as being x2, y2. Now given this, what we need to do is to go down and say first, let the intersection point of the lines L and L dash be Q. Now given that we can see the perpendicular distance we're looking for, the perpendicular distance from the point P to the line L is going to be directly equal to PQ. So we can say, therefore, perpendicular distance of P to L is equal to the length PQ. And therefore, to answer our question, all we need to do is to find the value of the length PQ. Now, considering PQ, we can see a bunch of interesting properties in the point Q. First off, the point Q is on the line L dash. According to that, since any point on the line L dash that we just defined can be given by this form, the point Q must also be able to be expressed in this form, x1 plus at, y1 plus bt, where the value t is some element of the real numbers and x1, y, and y1 are the coordinates of the point P. So according to that, we can say, since Q is on L dash, it can be given as the form of x1 plus at, y1 plus bt. And we'll say, let the corresponding value of t be, and we'll put special value. In my case, let's say we could put t1 or something. So t1 is the special value of q, special value of this point t, this value t, for which we get the point q. Now according to that, if we substitute, we can see q is therefore going to be given by x1 plus a times the special value of t, which is t1, y1 plus b times the special value of t, which is t1. And therefore the coordinates of q is going to be given like so. Now considering this, if we take a look at the perpendicular distance PQ, we can see PQ would be equal to the square root of the x distance squared, which is going to be x2 minus x1 squared, plus the y distance squared, which is going to be y2 minus y1 squared. Since the coordinates of q are x2, y2, and the coordinates of p are x1, y1. Now here, what I'm going to do is to substitute in x2 and y2 as these two coordinates that we just found based on the result that we found just before we started this question. So I'm going to substitute in the value of x2 as x1 plus at1 and y2 as y1 plus bt1. Now doing so, we can see from this we get equals square root, and instead of x2 we have x1 plus at1 and then minus x1 squared, and instead of y2 we have y1 plus bt1 minus y1 squared inside of the square root. And here we can see x1 and x1 here cancel and y1 and y1 here cancel, and therefore we're left with the square root of, and on the inside we have at1 squared, which will be a squared t1 squared, plus, and over here we're going to be left with bt1 squared, which is going to be b squared times t1 squared. Now factoring out the t1 squared, we can see we get square root of a squared plus b squared times t1 squared, and therefore we can write this being equal to the square root of a squared plus b squared times the square root of t1 squared. Now here I can simplify the square root of t1 squared to simply be equal to the modulus of t1, since by definition square root of t1 squared is simply going to be modulus of t1. And therefore we get this equation for the length PQ. PQ, our perpendicular distance that we want, is equal to square root of a squared plus b squared times the modulus of t1. This is going to be equation number 1. Now in here we already know NB. What we don't know is the value of t1. So for this we need to find the value of t1 from somewhere else and then use that in order to substitute and simplify to get the answer given in the question. Now for this, we need to use the other special property of the point Q. We already used the fact that Q is on the line L dash. What we need to use now is the fact that Q is also on the line L. Now since Q is on the line L, it must satisfy the equation AX plus BY plus C equals 0. So going down, we can say since Q is on the line L, we must have A times X, which is X2, which in this case can be written as X1 plus AT1, X1 plus AT1 plus B times Y, which in this case is Y2, which is going to be Y1 plus BT1. So we can write plus B times Y1 plus BT1 plus C must be equal to 0. Now if we rearrange this, we can see by expansion, we get AX1 plus A times AT1, which is going to be A squared T1 plus BY1 plus B squared times T1 plus C equals 0. Now taking these two on the left hand side and taking the other three terms right hand side, we can see if we factorize out the T1, we get A squared plus B squared times T1 equals minus AX1 minus BY1, actually minus C, and that's the equation we get. And rearranging this, we can see we get T1 equals minus AX1 plus BY1 plus C divided by A squared plus B squared. So we get divided by A squared plus B squared. This is the value of T1, and I'm going to call this equation number 2. Now considering 1 and 2, we can see if we substitute 2 into 1 by doing 2 comma 1, instead we're going to get PQ equals square root of A squared plus B squared multiplied by the modulus of T1, which is going to be the modulus of this entire expression on the inside. So you can copy this whole thing and paste it right in to the inside of the modulus. And that is our equation for the length PQ. Now simplifying this down, we can see the minus sign could be cancelled since we're inside a modulus, and since A squared plus B squared is going to be positive since A and B are both real numbers, we can remove the modulus from the denominator. And therefore, we can get the equation PQ equals square root of A squared plus B squared times modulus of the thing on the inside on top, which is AX1 plus BY1 plus C divided by A squared plus B squared. Now since A squared plus B squared is not equal to 0, there's nothing wrong here, and it also means we can cancel this for this, and on the denominator we can write only square root of A squared plus B squared, and therefore we can simplify to get the equation PQ equals modulus of AX1 plus BY1 plus C divided by the square root of A squared plus B squared. And that is the end of that question. We have found the perpendicular distance from the point P to the line L, which is PQ, which we've just found is exactly equal to the formula they gave us, modulus of AX1 plus BY1 plus C divided by square root of A squared plus B squared. Now here it's very important that you do it this way and not by directly substituting the known formula for the perpendicular distance of a point from a line in the form AX plus BY plus C equals 0. Now moving on from that, the question then says, let L be the straight line x plus y minus 2 equals 0. And given that, we are asked to show that A and B, these 2 points 0, 6 and 3, negative 3, lie on opposite sides of the line L. Now for this, we need to know something about the equation AX plus BY plus C equals 0. So the 2 points we're interested in are A, which is 0, 6, and B, which is given by 3, negative 3. Now what we should know is that if you have a line in the form AX plus BY plus C equals 0, while the line is exactly the collection of all of the points for which this value is equal to 0, if you consider all of the points above the line and all of the points below the line, one set of these points is going to be the points for which AX plus BY plus C is less than 0, and the other set of points is going to be all the points for which AX plus by plus c is greater than 0. Now, according to this, if we consider multiplying the value gotten for ax plus by plus c for one point on one side of the line and the same value gotten for another point on the other side of the line, one of these values is going to be positive and the other will be negative. Therefore, if you multiply the two together, you are going to get a negative value. So if we have this point here, let's say x1, y1, and this point x2, y2, then we are guaranteed that ax1 plus by1 plus c times ax2 plus by2 plus c is going to be a negative number. Now conversely, if both points are on the same side of the line, they are either going to be both positive or they're both going to be negative. And according to that, their product will be positive. So therefore, if we substitute into ax plus by plus c for both points, and then we consider whether both of them multiplied together is positive or negative, we'll be able to say whether a and b are on the same side or opposite sides of the line. Now considering that, if we do substituting into ax plus by plus c, for a we get a times x, which is 0, plus b times y, which is b times 6, plus c, where b is equal to 1 and c is equal to minus 2 as given in the question, and therefore we're going to get 1 times 0 plus 1 times 6 minus 2, which is going to be equal to 6 minus 2, which is 4. And therefore, from the point A, we get the value of 4 for ax plus by plus c equals 0. Now, considering b, for the point B, we get a times 3 plus b times minus 3 plus c, which we substitute the values of a, b and c from our line. A is equal to 1, so we have 1 times 3. B is equal to 1, so we have 1 times minus 3. And c is equal to minus 2, so we get 3 minus 3 minus 2. These two cancel out, leaving us is minus 2, and therefore the value here is minus 2. Therefore, if you multiply the two together, 4 times minus 2 is equal to minus 8, which is clearly less than 0. Now, as I said, if the product of these two values here is negative, then the 2 points we're interested in are on opposite sides of the line that we're interested in. Therefore, if the line L is given by x plus y minus 2 equals 0, by substitution we can see A and B are on opposite sides of the line. So therefore, taking this result we can say, given this, therefore A and B are on opposite sides of the line L, which is given by x plus y minus 2 equals 0. And with that, we are done with that part of the question. Now moving on to the next part, the last part says, find the acute angle between the line L and the line AB. Now for this, we need to know both the gradient of the line L and the gradient of the line AB. The reason is, if we know the gradients of two lines, let's say these two lines, if one of them is M1 and the other is M2, and the acute angle between them is theta, then tan theta will be equal to the modulus of M1 minus M2 divided by 1 plus M1 M2. So therefore, if we know both the gradients of the line L and the line which is going to be the line in between the points AB, which I'll just call AB for now, then we can directly find the acute angle between those 2 points. Now considering that, we already know the gradient of the line L. Gradient of L is equal to, if you consider the x plus y minus 2, taking this other side, we get y equals minus x plus 2, and therefore the gradient is negative 1. So the gradient of L is negative 1. Now next, considering gradient of AB, gradient of AB, that can be found by doing y2 minus y1 divided by x2 minus x1. Now considering the points A and B, y2 is negative 3, y1 is 6, and then x2 is 3 and x1 is 0. Therefore we get minus 3 minus 6 divided by 3 minus 0. And therefore our gradient here is going to be equal to minus 9 divided by 3, which is minus 3. So the gradient of the line AB between the point A and the point B is equal to minus 3. Now, considering that we can see from our two gradients, if we do the substitution, we'll say let theta be the angle, or rather acute angle, between L and AB. We are going to get the equation tan theta equals modulus of minus 3 minus negative 1 divided by 1 plus negative 3 times negative 1. And simplifying this down, we can see on top we are going to get negative 2. So we're going to get modulus of negative 2 divided by 1 plus positive 3, which is going to be 1 plus 3, which is 4. So we get modulus of minus 2 divided by 4, which is equal to minus a half, modulus, which is going to be equal to plus a half. And therefore, tan theta is equal to half. Now with this, I can directly say that theta is equal to tan inverse of 1 over 2. How can I say this? I can say this since theta is an acute angle, we can say if the tangent of theta is equal to alpha, or let's say x, then theta would be equal to tan inverse of x. We can say if an angle is acute, let's say tan of alpha equals x. If alpha is an acute angle, means in between 0 and pi by 2 radians, then alpha would directly be equal to tan inverse of x. Now due to this, we can say directly theta equals tan inverse of a half because theta is in between 0 and pi by 2 radians. Now moving on to the second half of the question says find the equation of the circles S1 and S2 that have centers at the points A and B respectively and also are both just touching the line L. The question then says let C be the point of intersection of the line L and the line AB in between the 2 points A and B. Given this, we are asked to find the coordinates of the point C and are also asked to find the equation of the other common tangent that goes through the point C that is tangent to both the circles S1 and S2. The question then says show that the equation of the circle that passes through the origin bisects the circumference of the circle S1 and is orthogonal to the circle S2 is given by the equation 3x squared plus 3y squared minus 38x minus 22y equals 0. Now to start with this question, let's consider where the circles S1 and S2 are, and given that, we'll try to find the equations of the circles S1 and S2. Now going down, I have actually drawn a diagram for this situation. Here you can see we have the line L and we also have two circles, one centered at the point A and another centered at the point B. Now here we can see, since both of these circles just touch the line L is tangent to both of these circles. So here you can see, according to that, if I draw the line from the point A, the center of this circle, all the way up to this point, this line and the line L should be perpendicular to each other. Similarly, if I draw a line from the center B to the line L, this line is also going to be perpendicular to the line L. Now given this, we can easily find the equation of these two circles. The first circle, of course, on the left is the circle S1, and the second circle on the right is the circle S2. Now we already know the centers of these two circles. All we really need in order to find the equation of the two circles is the radius of them. And we can easily find that because we can see the radius of the circle S1 is simply this perpendicular distance and the radius of the circle S2 is simply this perpendicular distance. And we can find both of them using a formula that we found in the first part of the question. That's this formula right here. For any point P that is distant from the line L, the perpendicular distance of that point P given by x1, y1 from the line L is the modulus of ax1 plus by1 plus c divided by the square root of a squared plus b squared. We can apply that same principle to the 2 points A and B, and therefore we can find the radius of the circle S1 and the radius of the circle S2. So going down, I'm going to write radius of circle S1 And similarly, I'm going to write radius of circle S2, and I'm going to substitute in the formula that we found above. So the formula is equal to the modulus of ax1 plus by1 plus c divided by the square root of a squared plus b squared, where a, b and c are the three constants in the line L, and x1 and y1 are the two coordinates of our external point. So in our line L, we were told that the line L is given by x plus y minus 2 equals 0. Now according to that, if we consider this form, we can see a is equal to 1, b is equal to 1, and c is equal to negative 2. So according to that, if we substitute in this formula, we can see we're going to get modulus of 1 times x coordinate plus 1 times the y coordinate plus the constant c, which is minus 2, divided by the square root of a squared plus b squared, which is 1 squared plus 1 squared, for the value of the perpendicular distance of the point A from the line L, and therefore the radius of the circle S1. Similarly, for the other one, we're going to get modulus of 1 times the x coordinate plus 1 times the y coordinate minus 2 divided by the square root of 1 squared plus 1 squared. Now substituting the two coordinates, the coordinates of A are 0, 6, and the coordinates of B are 3, negative 3. And therefore, for the first one, we get 0, 6 here, and for the second one, we get 3 and negative 3. Now simplifying each of these down, we can see on top we have 0 plus 6 minus 2, which is 4, divided by root 2. So we have 4 over root 2, which is equal to 2 root 2. So that's our answer for the radius of the circle S1. Now similarly, if we consider radius of the circle S2, it's going to be equal to the modulus of 3 minus 2, and these two cancel, leaving us with minus 2. So we have minus 2 divided by root 2, which is root 2. So the answer here is modulus of minus 2, which is 2, divided by root 2, which is root 2. And therefore the radius of the circle S2 is root 2. Now given this, since we already know the centers, which are A and B, we can directly say equation of circle S1 is going to be given by x minus x0, which is going to be x minus 0 squared, plus y minus y0, which in this case is 6 squared minus 6 squared, equals radius squared, which is 2 root 2 whole thing squared. And similarly, the equation of the circle, equation of S2, is also going to be given by x minus x0, which is x minus 3 squared, plus y minus y0, which is y minus negative 3, which is y plus 3 squared, equals the radius squared, which is root 2 squared. Now simplifying these two down, we can see the first circle gives us x squared plus y squared and a minus 12y and a 36 here, and this part here gives us 2 root 2 squared, which is going to be equal to 8. So we get 36 minus 8, which is going to be equal to 28. So we get plus 28 equals 0. So the circle S1 is given by x squared plus y squared minus 12y plus 28 equals 0. Now considering the other circle, if we simplify, we get x squared. I'm going to take this y squared to the front, so we get plus y squared, and then we get minus 6x, and then plus 6y, and then here we get 9, here we get 9, and here we get a 4, or rather a 2 on the other side. So we get 9 plus 9, which is 18, minus 2, which is 16. So we get plus 16 equals 0 for the equation of the circle S2. So with that, we have found the equations of the circle S1 and S2. Now moving on from that, the question then says, let C be the point of intersection of the line L and the line AB, and given this, we are asked to find the coordinates of the point C. So considering that, we are asked to find the coordinates of this point right here, the point C, which I'm going to call x3, y3. Now there are actually two ways we can find this. One way is to realize that the angle here and the angle here are exactly the same, and this angle is 90 and this angle is 90, and therefore this triangle and this triangle are similar, and according to that, the ratio of this length to this length is equal to the ratio of this length to this length, and using that in order to find the coordinates of the point C. Another way we could do it is to consider the fact that the point C is the intersection of the line AB and the line L. I'm going to be using the second method because I honestly find it easier. So for this, we need to find the line L, which we already know, and the line AB. So I'm going to find AB. So for AB, we already know its gradient. The gradient of AB was found to be equal to -3. Now according to that, we can see if we consider AB is going to be given by y minus y0 equal m, which is -3 times x minus x0. Now considering the coordinates we will substitute here, I could substitute either a or b. It seems that b is going to be simpler, so I'm going to do 3 and -3. So for that I can see we have y minus -3, which can be y plus 3, equals -3 times x minus 3. So that's the equation of AB. Simplifying down, we can see we can get the form y equals minus 3x plus 9 minus 3, which is plus 6. So y equals minus 3x plus 6. That is one equation, and the other equation is the line L, which is x plus y minus 2 equals 0. Now what we can do is to consider these two equations, substitute one into the other, and get the intersection point of them, which is going to be the coordinates of C. So therefore we can see, since C is on L, we're going to have x3 plus y3 minus 2 equals 0. And since C is on the line AB, we are going to have y3 equal minus 3x3 plus 6. And combining these two, we can see we get x3 plus minus 3x3 plus 6 minus 2 equals 0. And rearranging this, we can see on the left hand side we get minus 2x3, and on the other side we can take this plus 6 and minus 2 to become plus 4. Taking that to the other side, we get minus 4. We get minus 2x3 equal minus 4. And dividing both sides by minus 2, we can see x3 is equal to 2. Now according to that, we can see if we substitute back over here, we get y equals minus 3x plus 6, which will be minus 3 times 2 plus 6, which is minus 6 plus 6, which is 0. And therefore y3 is equal to minus 3 times 2 plus 6, which is equal to 0. And therefore C is given the coordinates of 2, 0. So with that, we found the coordinates of C. The question then said, find also the equation of the other common tangent that goes through the point C, that is tangent to the circles S1 and S2. Now considering that one, what we can do is to take a look at the geometry and figure out what we know about this other tangent. So the other tangent is this line right here, the line that goes through the point C and also passes tangent to both the circles S1 and S2. So we're looking for this tangent line right here. Now considering this tangent, we can easily find it in multiple different methods. One easy method is to realize that the angle here in between the line L and the line AB was equal to theta that we found previously, and that same angle should be there in between the line AB and this other tangent that we're looking for. So for this tangent, I'm going to call it, let's say, L double dash. So L double dash has an angle of theta in between itself and the line AB. Now, for the two lines L double dash and AB, we can actually apply the same formula that we previously applied for the lines L and AB, and that is that the tangent of the angle between the two lines is equal to the modulus of m1 minus m2 divided by 1 plus m1 m2, where the values m1 and m2 are the two gradients of the two lines we're interested in. Now considering that, in this case, all we need to do is to apply a symbol to the gradient of L double dash and then apply the formula in order to find the gradient of L double dash. So going down, I'm going to say, let's say m be the gradient of L double dash. Now given this, the tangent of the angle between the two lines L double dash and AB, which is theta, is equal to the modulus of the first gradient, which is the gradient m, minus the second gradient, which is the gradient of AB, which we found previously is equal to -3, divided by 1 plus m1 m2. So we can write -3 divided by 1 plus m times -3. Now we can actually substitute and simplify a bunch of things here. We can first simplify tan of theta. Tan of theta was found to be previously equal to 1/2. Therefore, on the left hand side, we have 1 over 2, and considering the right hand side, we have 1 over 2 equals the modulus of m plus 3 divided by 1 minus 3m. Now, if we simplify this and rearrange, we can see, taking this 1 minus 3m to this side and this 2 to this side, we get the equation 1 minus 3m's modulus equals 2 times m plus 3's modulus. Now, when we have a situation where we have a modulus of one thing being equal to the modulus of another thing, it's either the case that this value is exactly equal to this value, or this value is equal to the negative number of this value. So therefore, either 1 minus 3m is equal to 2 times m plus 3, or it's equal to minus 2 times m plus 3. So it's equal to plus or minus 2 times m plus 3. Now from this, if we consider two cases separately, we can either have 1 minus 3m equals 2 times m plus 3, or 1 minus 3m equals negative 2 times m plus 3. Now simplifying each of these cases separately, for the left hand side, we have 1 minus 3m equal 2m plus 6, which we can rearrange by taking this 3m to this side and this 6 to this side, leaving us with 1 minus 6 equal 3m plus 2m, giving us minus 5 equals 5m, and therefore the value of m equals negative 1. This is one of the solutions. Now considering the other solution, we have 1 minus 3m equal minus 2m minus 6, and we can rearrange by taking this 3m to this side and this 6 to this side, leaving us with 1 plus 6 equal 3m minus 2m, leaving us with the solution of 7 equals m, and therefore m equals 7. So either m is equal to negative 1 or m is equal to 7. Now the reason we get two solutions is because there are actually two lines that each have an angle of theta in between themselves and the line AB. Now if we consider a diagram, we can see one of the two lines that has an angle of theta in between itself and the line AB is the line L. And looking at the line L, we can see the gradient of L that we found previously as well is equal to negative 1. So therefore, the value of m equals negative 1 that we got here is the gradient of the line L. According to that, the other gradient value we got, which is m equals 7, must be the gradient of the other line that has an angle of theta in between itself and AB, which is the line L double dash. So we can say, since L has a gradient of negative 1, the other line must have the gradient of m equals 7. And therefore, we can say L double dash has a gradient of 7. Now with this, we can actually directly find the equation of the line L double dash. We can find it from the fact that not only does L double dash have a gradient of 7, it also passes through the point C, which is x3, y3, which we just found to be equal to 2, 0. According to that, if we substitute the formula y minus y0 equals m times x minus x0, we can get L double dash being given by y minus 0 equals 7 times x minus 2. This is the formula for the line L double dash. Now simplifying this down, we can see we can get L double dash being equal to, and if I simplify this into the form of ax plus by plus c equals 0, we can get 7x minus y minus 14 equals 0. And that is going to be our answer for the other tangent line to the circles S1 and S2 that passes through the point C. Now after that, the question then says, show that the equation of the circle that passes through the center origin bisects the circumference of S1 and also is orthogonal to the circle S2 is this equation 3x squared plus 3y squared minus 38x minus 22y equals 0. Now considering the circle, if this circle, which I'll call, let's say, let the circle, we'll say, actually we'll just write out what it does. That passes through the origin, bisects the circumference of circle S1 and is orthogonal to the other circle S2, be the circle, we just call it S, okay? This circle S. Let this S circle be the circle that we want. And we'll also say this circle is given by the equation x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now, if this circle passes through the origin, we can say coordinates 0, 0 should satisfy S. Now, according to this, if we substitute, we should get 0 squared plus 0 squared plus 2 times g times 0 plus 2 times f times 0 plus c equals 0. And we can see everything else other than the c is already equal to 0. This is 0, this is 0, this is 0, and this is 0. So therefore, we get c equals 0. So out of the three unknowns here, f, g, and c, we have already found c. C is equal to 0. Now all we need to do is to find the values of g and f. Now for g and f, we have to use the other two conditions. The first condition is the circle S bisects the circumference of the circle S1. Now if we consider what this means geometrically, given the two circles S and S1 like so, if we consider their two intersection points, which are this point, and we draw the line in between them, which is this line right here, this line will be a chord of the circle S and will also be a chord of the circle S1. Due to that, we say that this line is the common chord of the circle S and the circle S1. Now, as it turns out, the common chord of two circles S and S1 will be given by the formula S minus S1 equals 0, where the circles S and S1 are both given in the form x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now in this particular case, you can see this common chord appears to pass through the center of the circle S1, which is the point A. As it turns out, when we say that one circle, let's say S, bisects the circumference of another circle, let's say S1, it means that the common chord passes through the center of that circle, and therefore the common chord becomes the diameter of that circle. Now the reason we said that this bisects the circumference of the second circle is because if you consider this diameter, it breaks the circle into two equal pieces, and if you consider two arc lengths, this arc length is equal to half of the circumference, and this arc length is also equal to half of the circumference, and therefore the circle S bisects the circumference of the circle S1. Now from this, what we can see is that given two circles S and S1, if the circle S bisects the circumference of the circle S1, it means that the line S minus S1 equals 0 must pass through the center of that circle, which is the point A. And we can use this information in order to form an equation in terms of f and g in order to find the values of f and g. So considering that, what I'm going to do first is to go down and say the common chord of the circles S and S1 is given by S minus S1 equals 0. Now substituting in these two circles, for S we have x squared plus y squared plus 2gx plus 2fy plus the value of c, which is equal to 0, as we just found. So therefore we have plus 0. Now closing that bracket, if we then consider the second circle, we have minus the second circle S1, which going up is given by this equation right here. So copying that down, we have x squared plus y squared plus 2gx plus 2fy minus x squared plus y squared minus 12y plus 28 equals 0. So this is the equation of the chord that is common to both S and S1. Now simplifying this, we can see we can cancel this x squared and y squared for this x squared and y squared, and from the rest we can see we have 2gx, a 2fy, and a minus 12y times minus 1, which is plus 12y, which if we factor out the y, we're going to get plus 2f plus 12 times y, and then we're going to finally have minus 28 equals 0. So this is the equation for the common chord of the circle S and the circle S1. Now from our information, what we know is that the point A, which is given by 0, 6, must be on this line. So we can say therefore since a, which is given by 0, 6, is on the common chord, if we substitute the coordinates of x equals 0 and y equals 6 in this equation, it should be satisfied. And therefore we can say 2g times 0 plus 2f plus 12 times y, which is 6, minus 28 must be equal to 0. Now simplifying this down, we can see we have 0 plus 2f times 6, which is 12f, plus 12 times 6, which is going to be equal to 72, so plus 72, minus 28 must be equal to 0. Now simplifying this down, we can see we have 12f equal to, and then we have negative 72 minus 28. So 72 minus 28 is going to be equal to, this is 40, and then minus another 8, which is going to be minus 6. It's going to be equal to, no, not 33. It's equal to, this is 50 minus 6, which is 44. And then if we simplify this, we can see we're going to get f equals negative 1103. So that's our answer. F equals negative 1103. Now with this, we can try to find the other value, which is the value of g. Now for the value of g, we reduce the other condition that we were given, which is the fact that this circle is also orthogonal to the circle S2. Now if two circles are orthogonal, what it means is that if you consider their two equations in the standard form of x squared plus y squared plus 2fx plus 2gy, or rather 2gx plus 2fy plus c equals 0, then for the two circles, 2f1 f2 plus 2g1 g2 must be equal to c1 plus c2. Now considering this, if we consider two circles, which are the circle S, which is already known by this equation, where we already know the value of the value f, which is equal to negative 1103, and the other circle, which is circle S2, which is given by this equation, we can see, actually I'll copy this down just for clarity. I'll copy this down over here, and I'll also copy down the other circle S, which is given by, where is it? This circle, which is given by this equation. I'll copy it down over here, and here we have to substitute c equals 0, and also substitute f, which is equal to negative 1103. So we can substitute into here 2 times negative 1103 times y equals 0. According to that, if these two circles, if S and S2 are orthogonal, we must have 2 times the first constant, which is g. So 2 times g times the second constant, which is going to be equal to negative 3, since this right here is equal to 2g, times negative 3 plus 2 times the first constant, which is f, which is negative 1103, times the second constant, which is g, which is here positive 3 plus 3, must be equal to the first constant, which is 0, plus the second constant, which is 16. So we must have this equation right here. Now simplifying this down, we can see here we have negative 6, so we have negative 6g, and then we have plus 2 times minus 11 times 3 divided by 3, which these two cancel, leaving us with minus 22. So we have minus 22 equals 16, and therefore we get g equals 38 divided by 6, or rather divided by negative 6. So we get g equals negative 19 over 3. So with that, we have found the values of f and g, and therefore can finally write down the equation of the circle S. So circle S is given by x squared plus y squared plus 2gx, which is 2, negative 19 over 3, x plus 2fy, which is 2, negative 11 over 3, y plus 0, which is just write as nothing, equals 0. Now this equation is not exactly what they had up here. Instead, they had everything multiplied by 3. So therefore, we're going to do the same and multiply everything by 3. So doing so, we can see we're going to get, instead of x squared, s given by 3x squared plus 3y squared. This 3 is going to go away, leaving us with minus 19 times 2, which is minus 38x, and then 2 times minus 11, which is minus 22y, equals 0. And with that, we are done with this question. So now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you get the correct gradient for the second line, and then you substitute in like this to get L dash given by y minus y1 equal b over a times x minus x1, for this you get 5 marks. After that, when you simplify and rearrange into this form right here, you get another 5 marks. After that, when you introduce the parameter, solve the two equations separately and get these two parametric equations, and then as a conclusion say this, you get another 5 marks. Now after that, in the next part of the question, when you consider PQ and the perpendicular distance and define some stuff and go down and then consider what PQ actually is, given that you know Q is on the line L dash and therefore we'll have these kinds of coordinates, for solving this, you get 5 marks. After that, when you simplify down, cancel this x1 and this x1, this y1 and this y1 to get to this point and say the perpendicular distance PQ is equal to the square root of a squared plus b squared times the modulus of t1, you get 5 marks. Now after that, when you then use the fact that Q is on L to derive this equation, simplify it down to find the value of t1 like so, getting to this point gets you another 5 marks. Now after that, when you then combine the two equations together, simplify, do a bunch of cancelling, and get to this point right here, where you have the perpendicular distance PQ being equal to exactly what they gave in the question, you get a final 5 marks. Now after that, when they give you the points A and B and ask you to find them on opposite sides of the line, for first finding the value of ax plus by plus c, for each of them you get 5 marks, and then when you multiply, see that's a negative number, and then conclude that they're on opposite sides, you get another 5 marks. Now after this, in the next part of the question, when you find the gradient of AB as being equal to negative 3, you get 5 marks, and then when you substitute into the angle formula and say tan theta is equal to minus 3 minus negative 1 divided by 1 plus minus 3 times minus 1, you get 5 marks of that, and then upon simplification, when you get to this point, tan theta is a half, and then say theta equals tan inverse a half, you get another 5 marks. Now after that, in the second half of the question, when you draw these circles and then realize that the radius of S1 must be equal to the perpendicular distance here, substitute the formula and get the answer. For the formula substitution and realizing you need the formula, you get 5 marks, and after that for the final answer, you get another 5 marks for each of the two circles. So 10 marks for the first circle and 10 marks for the second circle. Now after that, when you use these two values of radii and the two center points to find the two equations of S1 and S2, for S1 you get 5 marks, and for S2 you get another 5 marks. Now after that, when you consider AB, draw out its line and then consider the fact that C is on L and AB both at the same time in order to find an equations, simplify and get x equals 2 and then get y equals 0. For getting that bit, this bit right here, you get 5 marks. And then later, for getting this bit, you get another 5 marks for finally finding the value of C, which is 2, 0. Now after that, when you then let M be the gradient of the second line L double dash and then substitute this formula, you get 5 marks of substitution, and going down, when you then get the two values of M equals negative 1 and M equals 7 and conclude that since this negative 1 value is already there in the line L, the other value of M equals 7 must be the gradient of the line L double dash and conclude that, you get 5 marks, and then when you substitute and get the final equation of L double dash as this equation right here, you get another 5 marks. Now moving on from that, for the last part, which is about the circle, when you conclude that C is equal to 0 based on the fact that 0, 0, you substitute into circle S and get C equals 0, you get 5 marks. And after that, when you go down and consider the second condition, which says that the circle S bisects the circumference of the circle S1 and get these equations right here, for the equation of the common chord, you get 5 marks. For substituting in the coordinate 0, 6, you get 5 marks. And then for getting the value of f as negative 1103, you get another 5 marks. Now after that, when you apply the condition of orthogonality, which is this condition, to the circle S and the circle S2, in order to get this equation right here, you get 5 marks. And going down, when you simplify this to get the value of g as g equals negative 1903, you get another 5 marks. And finally, when you substitute this value of g and this value of f into your equation to get the circle S as 3x squared plus 3y squared minus 38x minus 22y equals 0, you get a final 5 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.